Good afternoon. Hi, I'm William Vabenet. I'm a product manager at Google. More specifically, I lead the product management team for big data services on Google Cloud Platform. And if I find my clicker, I think we have a really good session today, in large part because you're only going to hear the Google perspective for a small portion of the presentation. I'll give a quick overview of the platform, and then most of the session time will actually be with customers coming up on stage and describing how they use the platform. So Penny Jackson from Jaguar Land Rover will come, and then James Tromans from Citi is going to come and describe their usage of the platform. So before that, I want to give a short overview of the platform, mostly to situate how the services that they describe fit in a larger context, and also because in the end, as cool as individual services are, what's really useful is how they all fit together in the platform. That's where the true benefit is. And a lot of our work in the platform is focused on efficiency and productivity of the bigger picture. And when I say efficiency, I don't mean just the technical efficiency, having the hardware efficiency, the great network, the processing algorithm, the query engine. That goes without saying. That's a given, that we work hard on making those efficient, just because at the scale at which Google itself runs, plus all the customers now on cloud, any efficiency gain has a really big financial benefit. So that part is actually a given when I say efficiency. The part which is actually more important from my perspective is the human efficiency, the productivity of people who use the platform, be they developer, be they analyst, data scientist, people who actually bring their business problem, their business expertise to the platform, and giving them tools that allow them to focus only on that, focus on their knowledge of the business and what they want to get done. And the way we do that is by assembling a platform that combines the best of open source with cloud-native services that gives you the best efficiency on cloud. And so, speaking of cloud-native services, one example is Cloud PubSub. So you can read that from left to right, kind of following the life cycle of the data from the point of ingestion all the way to usage. And so on the upstream, in case your data arrive in the form of events, Cloud PubSub is a reliable event delivery system fully managed by Google. Example of a cloud-native service where you have nothing to do other than creating a topic and then sending messages, consuming messages, and paying exactly for what you need, including zero if you have a topic that does not get any traffic. On the other end of the spectrum, from a data lifecycle perspective, something like Cloud ML, Cloud Machine Learning, and hopefully many of you saw the session this morning where Fausto talked about machine learning at Google and how Cloud ML allows you to use Google's own training infrastructure and prediction infrastructure to train your TensorFlow model. So these are two examples of really bringing the tools that run Google to our customers. But I also mentioned the best of open source, especially in big data. There is a thriving community in open source, mostly in Apache, around Spark and Hadoop mostly, and tools built on top of those. And in many cases, the right tool for the job comes from that ecosystem. It's a library, it's a tool that somebody wrote to run on Spark and Hadoop. And when that's the case, you should be able to use that for that specific need without having to give up on cloud-native services. And the way we allow that to happen is via Cloud Data Proc here, which is our managed Hadoop and Spark service. And so with Data Proc, we give you a Hadoop or Spark cluster in under 90 seconds, from state zero, from the point of saying I want one, to the point of having a cluster, hundreds of nodes ready to work for you. That's 90 seconds, billed by the minutes, gives you access to all the tools of the Hadoop ecosystem. And you can complement that with cloud, and you can use that to complement cloud-native services. So speaking of cloud-native services, there are only two of them I'm going to spend a bit more time on because they are the two most relevant to what Penny and James are going to describe after. I'll start with Cloud Data Flow. You see it twice here. There's only one Cloud Data Flow. The reason why it shows up twice is because it can be used upstream as part of data ingestion to prepare data before storage to do real-time analytics. It can also be used downstream on historical data. Wherever it's being stored, Cloud Data Store can use and process it. And the reason why it's so versatile and can be used upstream and downstream is because of its programming model. The Cloud Data Flow model can unify batch and stream. In effect, it creates a perfect world. And what I mean by that is, in reality, data arrives in different ways. Maybe it arrives in batch every 4 hours, every 8 hours, 24 hours. Maybe it arrives in a stream. Even if it arrives in a stream, most of the time events don't arrive in order. If they're collected by cell phones, there is a delay, and the delay is not the same. And so when you write your processing logic, you have to deal with the complexity of figuring out how the order in which you see the data, which is the processing time, maps to the order in which things happen, which is the event time. In the ideal world, everything would be on this line, but in reality, they're not. All the events are there. The data flow programming model, which I can't describe in detail right now, but these slides kind of, I could describe all the aspects of this graph. What it lets you do is write your business logic in an ideal world where every event is available right away and in order. And so you can say exactly how you want events grouped by time window, by session, any key that you want to group them on, and you write your business logic in a very clean, modular way. And then Cloud Data Flow does the hard work for you of mapping that to the messiness of the real world. And if your events arrive in batch, we map that to a batch pipeline. If they arrive as a stream, we map that to a stream of event, including keeping track of a watermark, which is that green line, which is our approximation of a heuristic of when we think the events have arrived, how we deal with late events, how we optimize by early triggering, things like that. So everything that maps the beautiful ideal world where you write your business logic to the messiness of the real world is on us, and that's what the data flow programming model gives you. What's interesting too is that even though this came from Google, this is not unique to Google anymore. Data flow is now in Apache. There is a runner for Spark. There is a runner for Flink. So data flow itself, as the Google service, is just one runner among many. But the same data flow pipeline that you write can run on all of those. And so Apache Beam is the name of the project where we submitted the data flow model. And the name is easy to remember because it's the B of batch and the EAM of stream put together. So that's what Beam is, batch and stream, unified and portable. If you choose to run them on Google Cloud Data Flow, you take your Beam program, you benefit from a cloud-native service. You don't have to deploy or manage anything. You just submit a pipeline and tell us, run that pipeline for me. And we'll run it for you in batch mode, in stream mode, depending on what inputs your pipeline reads from. We'll auto-scale it. We'll bring all the optimizations that we've learned over 15 and more years of doing big data at Google, starting with MapReduce 15 years ago, and all the improvements since then. All those lessons are reflected in the way we run data flow for you on Google Cloud Platform. So that's data flow. The other service I'm going to highlight quickly is BigQuery, and that's our data warehouse. And BigQuery, it's the easiest service to love of all Google Cloud services, I would say of all cloud services. And the reason why it's so easy to love is because it does so much for so little effort. With BigQuery, literally, all you have to do is write a SQL query, and you can process data of any size and run very complex queries. Or if you use a tool that generates SQL for you, you use Looker, you use Tableau, any of those tools, then you don't even have to write SQL. And so you can process terabytes, petabytes of data. You can merge data, your data, partner data, public data, and you can get so much done with no effort whatsoever. All the infrastructure, all the storage, there is nothing to deploy. You just write your query, submit the query, and we run it for you. And so on the consumer side, data scientists, business analysts, developers really love using BigQuery and talk highly about it. What we've done is we've also made it easy to love by the CIO and by the IT decision maker. Because what we've done is we've taken the power of BigQuery and we've made it compatible and harmonized it with the tools and processes of typical enterprise. So BigQuery used to have a special dialect, which is based on the way we did it at Google. And it was actually very close to SQL, but it wasn't quite the same, and so there is some work to learn the new dialect. Now we use standard ANSI SQL, so that's gone. We've developed a really large a very large ecosystem of partners for data ingestion, for BI, for visualization. So, whether it's an ETL vendor or a BI or visualization vendor, most likely your current tool is a BigQuery partner. If not, we now have ODBC drivers, JDBC, they're coming out next week or the week after, so you can really connect any tool that way. We've added update and delete function. Again, BigQuery used to be append only, which was fine because you can rematerialize a table very quickly, but still, it's a conceptual burden you shouldn't have to deal with. So you can just do update and delete now in BigQuery. Fine-grained security via IAM integration is also really important for enterprise users. So a given application can be given permission only to do streaming ingestion, only to do batch load, only to do query. And this way you can be really careful in how you give permission to applications or to individual to use BigQuery. And we've integrated with the monitoring console, which is especially important because of that last point, that we now offer the option of purchasing BigQuery via a flat rate pricing. So historically, BigQuery has been fully on demand in the sense that you pay for every query separately, and then you pay for storage. And this way, if you go on holiday for a week and you don't run any query, you're just paying for storage. You don't have a data warehouse sitting there doing nothing. You just have storage, very cheap storage, 2 cents per gig, which becomes 1 cent per gig after 90 days. But for the queries, you pay exactly for what you need, which is really nice and really efficient, but also hard to predict and hard to budget. And so for enterprises especially, there's been a lot of demand to bring predictability. And so now, in addition to on-demand, which of course is available, you also have the option on the query side to pay a flat rate every month. And so storage is always on demand. If you are using 2.5 terabytes, you pay for 2.5 terabytes. And next week, maybe it's 2.6. So pay exactly for what you use. On the query side, you can pay for exactly what you're using and pay for each query. Or you can have a flat rate, and then you can run as many queries as you want, and you don't pay extra per query. And via the monitoring integration, you can see exactly how is your consumption mapping to what you've purchased. And maybe you need to buy more, maybe you've bought too much, and you can downgrade your subscription, and you control that every month, the same price. So very easy to control, very easy to predict. So I spent a bit more time on Dataflow on BigQuery because I want to set the stage for Penny and James, who are coming next, who are going to describe in practice how they use it and what value they're getting from it. So first, Penny Jackson, please, from Jaguar Land Rover.
Hello, everyone. I'm Penny Jackson from Jaguar Land Rover, so introduced by William. I'm here to talk about EDW on Google Cloud, our plans for it, and our journey to get there. First thing I'm going to talk about is an earlier stage of our life cycle. I joined Jaguar Land Rover in January last year, and one of the first priorities I was given by my manager was to do something about analytics enablement and supporting data workers in our business. We've got a very data literate user base, very technically literate as well, as you might expect from an engineering company. Everybody knows how to create a solution. So we had an army of people in our engineering, in our marketing departments who were just getting SQL, getting Access, getting Excel, and getting into trouble, essentially, or only getting so far with what they could do with data. So we were already a Google adopter in terms of mail and calendar. We hadn't done a lot with the cloud platform side. So we investigated, and as William was saying, the key sort of products to love, the easy adopters, from what we'd looked at were cloud storage as a storage bucket and BigQuery. So we created a data lake from those two products and what we've called an analytics data lab. So that's made available to those products certain of our visualization tools. We use Tableau in-house, we have R and MATLAB. So that basically getting the data available, or a platform in which the data could be available in a data lake, and tooling to work on it that could then be deployed to the wider business community. And a lab management service, which was really some know-how, and I need a work area quickly, please get me something set up. So the objective was that it was not an IT-delivered solution, that it was a data collaboration area that with a minimal amount of training, our business users could upskill away from their desktop tooling and get up and running. And that's been really successful in the 8-9 months that we've been running this. We've got 37 business groups who are using it at that early stage of life cycle, investigating data, trialing, visualization, and getting stuff out there in a sort of rapid prototyping cycle. We've had some analytics pilots that have actually pointed the opportunity of some real ROI, so around $500,000 opportunity of energy saving at one of our manufacturing plants, simply from being able to look at data off the plant floor in this vehicle. And we've also made sure that the platform, because it's cloud and because you can externalize it, our business are able to bring in their favorite providers. So if they're working with somebody, one of our suppliers who's got an automotive specialism, or they're working with another big data partner because they need some arms, legs, and expertise to do so, we're able to bring them into this environment and enable collaboration with external parties as well. So that's great for the early stage of your sort of data progression life cycle, but it's not really starting to attack the problem that we also have internally of a lot of structured control data being in very different silos. So we started to think, what if? With the Google Platform as a Service capabilities, and as William mentioned, all those interconnected tooling that allow you to ingest the data in any form, it's coming right the way through to analyzing. What if we could actually apply, with a combination of those toolings, a more control environment approach, and build an EDW in the same location, so that when our business have finished piloting and prototyping, we don't actually have to tell them to move platform. We don't have to tell them to move their data again and move on to another technology set. So can we actually take some of that life cycle of development, moving from the experimental through to the gold standard reporting? So earlier in this year, in Q2, I set my team out to assess that. Now, it's quite an important cultural point that we've also learnt through this journey. We have Google as a strategy. I get a lot of pressure from the top about why aren't we using it more and can we use it more. It's very counterproductive, I feel, to tell your teams that that's the answer and push them onto it. They have to feel comfortable about it themselves. And particularly when, as I inherited a very good and strong team of data professionals who'd been delivering data warehouses for years, and all the challenges that brings, they had to convince themselves that this was the right route to go and develop an architecture and a design pattern that they were comfortable with. So I liberated them from their day-to-day project work and said, go work on what you think you need to do to see whether this is actually practical. And this is where we got to. So 5 months of proof of technology. We think we've confirmed that we can satisfy all the controls and performance we need for an EDW in the data lake environment. So that's using principally our on-premise ETL tools, BigQuery, Cloud SQL as the relational structured part of it, and data flow. And then at the top, to surface it, we've got a virtualization tool that will allow us to put a semantic layer and Tableau on top of that. I'll come on in a minute to talk about what the layers look like and how it's constructed, but essentially we've got a BigQuery layer as the access layer at the top. Now, that's quite a discovery for us, because I think when we started the journey, or when my technicians and data architects started the journey, they were probably envisaging that they had something much more traditional at that top layer for the business to access, that it would be in a star schema, Kimball model type style thing. But with the way that our thinking's gone and understanding what the power of having a denormalized data set for the business to query and plug Tableau into for reporting in a much more analytical way, we can get all the benefits, all the power and the processing, but still have the controls with the way the data arrives in there. And these are some of the stats. We've tried our real data sets from existing data warehouses, and loading them against some very big dimensions. And you can see for yourself, we're talking minutes of a truncate load type build time on BigQuery. Obviously, the ability to append and insert now may change us even needing to do that, but we were testing against a worst case scenario that we might have to wipe that access layer and rebuild it every time we got a delta load with our dimensions. We're also able to use with data flow, being able to swap out a replica BigQuery table. We think we can achieve zero downtime for our users, so that once you've loaded, you just flick over. And all of that from a cost of storage and not having to nurse and love the infrastructure that it sits on is going to save us, we believe, a considerable amount of IT support cost, licensing cost, and storage cost as well. So this is a little bit about the architecture in overview. So we're bringing delta changes to facts and dimensions through Cloud SQL as a relational model in order to conform them. So all that traditional data control is applied as the data is coming in, and the ETL tool is writing directly into Cloud SQL with those delta changes. And we've got impressive performance, Oracle-like performance, if that means something to people in the room, out of Cloud SQL from that ETL write. So we're very comfortable that certainly with our internal structured data volumes that we're achieving what we need with that delta load. Then essentially we're archiving that off to a BigQuery table so that the data volume that isn't going to change are facts that don't change. We can keep in something that's much more performant. And then data flow is streaming that up into the access layer. And I think that's a repeat there of our stats. So this is essentially what it looks like in a very simplified manner. We've got either files or structured data sources being processed in, either written directly into Cloud SQL, or the files are coming through cloud storage and then being acted on. We've got a fax archive, and then streaming that up into our access layer on the denormalized data mart. Any of our visualization tools we can plug in through either the DV or even, and this is where the world moves on, even when you think you've got an answer, things are moving fast. We've also got a question about whether we're actually going to be plugging in directly to BigQuery if we can get those tables nicely labeled. But I think the virtualization is really there to provide us a little bit of insulation of anything that we might want to change structure-wise underneath.
All right. Thank you, Penny. And now, James. Thank you. And now, James Tromans from Citi. All yours.
Thanks, William. OK, so my name's James Tromans. I'm working just across the river at Citi in Canary Wharf. I work in foreign exchange and local markets. That's the FXLM piece. Citi FXLM is in 70 countries worldwide. We're delivering technology globally. And my role and responsibilities are around our front office risk systems. But today, I'm going to be primarily talking about data. And I'm really excited to be talking about some of the research we did at looking at how Google Cloud Platform could help us innovate with our data. We'll go through the specific use case that I spoke about this morning in the keynote on exactly what the data challenge we had was and why we were using Google Cloud Platform for that. So Just to sort of link it back to the keynote, Google, Thomson Reuters, and Citi worked together in partnership. We genuinely just kind of got into a room together. We started shooting ideas around on what we could do with Google Cloud Platform that would add value. And I think it's very tempting when you're in that situation to look inward and look at the data that you're generating. And for us, at least, right now, that's still a challenge if we want to just shift and move that data into the public cloud. There's a lot of sensitivity around that, and rightly so. We want to do that, but we want to take our time. We want to make sure we do it right, safely, and securely. So instead of doing that, we spoke to Reuters, and they were able to kindly give us their market data into the Google Cloud Platform for a proof of concept. So working in partnership together, there's key individuals. You have to have a proof of concept where you've got a single point of contact at each place. Otherwise, it just doesn't go anywhere. But once we had that, we kickstarted the proof of concept to see if we could load historical market data into Citi and real time. And because we had the Google Cloud Platform at our fingertips, we were then able to bring compute to bear on that data. And I'll talk a little bit about that as well. So in terms of the technology ecosystem that we adopted for the proof of concept, it was obviously BigQuery, it was PubSub, and Dataflow. So just a small thought experiment to get everyone thinking in the same way, so you can understand the challenge that we were trying to solve for with the proof of concept. Think about your mobile phone, or think about one mobile phone. What's its price? Maybe it came out 15 months ago. Maybe it's running Android. It's working well. But is it worth £200 today, £400 today, £600? What's the fair value? I think as you go through sort of thinking to yourself, how did you come up with that answer, you probably thought about, well, what was it released at? What was the price that it came out at? And you're discounting through time, maybe. It gets a bit older now, so it's not worth what it was when it first came out. Maybe better still, you saw it advertised recently. Or best yet, maybe you actually saw someone buy one yesterday, or you bought one yesterday. But what you quickly realize is when you're buying something, you want to buy it for the least amount possible. And when you're selling something, you want to sell it for the most amount possible. So sometimes you have two prices. And the difference between the price you're willing to buy at and the price you're willing to sell at is called the spread. And sometimes people just can't agree. And so a question, what is the price, can be a little bit complicated. And so the data that we're getting from Thomson Reuters, we ran through PubSub and BigQuery and Dataflow to try and build sort of some analytics around that. And I'll just talk through the specific example that we chose to try. So just to orientate you to what you're seeing, I know it's late in the day, but I promise this isn't too complicated. X-axis is time, chronologically, going from older to newer, left to right. And the y-axis is the asset price, the price of the phone. Okay? Each red dot is a price observation. It's literally a trade. So if we just start on the left-hand side, you've got a price observation there. Then the price kind of goes up. Then it goes up a bit more. Then it drops down. Then it gets even lower. And then it kind of goes back to where it started. And then there's some quiet. For whatever reason, we don't know at this stage, there were no trades. And then they kick back in again, and it kind of arcs up and then ends up finishing off downwards. So when we're thinking to ourselves, what's the price? Well, at the end of the day, people got together and did these trades. So that's probably as good an estimate as any as what the current market value is. So I put a dotted line going forward through time that follows through the last trade, and you get this kind of step function. So imagine if I were to remove all the red dots, you just kind of get this dotted step line. But from here, I might want to do some analyses to understand, OK, the price is changing, but why is it changing? Maybe it's correlated to the silicon. Maybe it's correlated to the price of the screen, or whatever. So to do that, I have to normalize my data in some way. You can't just compare independent random samples through time with other independent random samples through time. You have to find a way to make them comparable. So to do this, we drop in these time windows. There's 3 here. You've got one on the left, one in the middle, and one on the right. And next, we can create some sort of descriptive statistics of what happened in that time window. So take the time window on the right-hand side here. Starting from the right-hand side as well, you've got the close. Now, the close is just the last price observation that we saw in that time window. So you can imagine we've got Dataflow and PubSub running here with real-time market data flowing through. We've got these time windows now. We want to look at what the last value was in a given time window. And in this case, the last value was also the lowest value. We also keep track of the high. And in almost all cases, the open value for that time window is the close of the previous time window. So in this case, because there were no price observations in the middle window, we just carried forward the close from the first window all the way through. Once you've got those values, you can build these candlesticks. So anyone who's looked at a stock chart before, you'll begin to be familiar with this. I'll just walk you through it. The time window on the left, you've got a green rectangle with two lines, one's protruding upwards and one's protruding downwards. The upward line represents the high, the downward line represents the low. The rectangle itself is green. That's because the price went up in that time window. So in this case, the bottom of the rectangle is an open, and the top of the rectangle is a close, and we shaded it in green to represent that. And then moving to the right-hand side of the diagram, you've got the red candle as well. So as I said earlier, the close and the low were the same, so there's no protruding bottom line, but we still have the high line. And because the price opened at a higher value than it closed at, we shaded it in red. So pretty simple. Once you've got these three candles, you can easily imagine how you might scale this out to have hundreds of them. And the time window that you choose can vary, right? Often it's minutely, hourly, daily, but why not have it 15 seconds or every 3 hours? The time window that you pick for your time series analysis will often depend on the amount of observations in your time buckets. If you have a very slow-moving asset that's not really having many trades or it's not really changing in price too much, you might choose to have a bigger window, and that might be relevant for your analytics at a later stage. If it's very high-frequency data, you'll probably want to analyze it at a smaller window. But what we can do with PubSub and Dataflow is do it all. We can create a bunch of different windows if we wanted to and have them all running in parallel. So once you have this, it's only a hop, skip, and a jump until you get some more complicated visual representations that you can produce from that underlying derived time series that we just produced. And we can do this by taking the close values of every one of those candles, and we could start correlating those closes with other assets like I just mentioned earlier. So when you've been doing this long enough, you begin to realize everything is a time series, whether it's the high-frequency market data that Thomson Reuters kindly provided for the proof of concept, or whether it's that relatively stagnant, static data that doesn't change too much. You can still express it as a time series. And so you start to build systems to accommodate for that fact. And I think what was very important for me was to understand, if I've got these types of systems, how do they fit within the Google Cloud Platform paradigm? How do I use Google's technologies to try and solve some of the problems that I have? So for the POC, we combined these three technologies, BigQuery, PubSub, and Dataflow that I mentioned. And we had three relatively simple objectives. Firstly, we wanted to access this downsampled historical market data that Thomson Reuters provided, and we wanted to put this into BigQuery so that we could run analytics at a later stage on it and load it back, maybe to populate charts or maybe to do something a bit more complicated. But that wasn't enough. We also wanted to keep this data up to date live streaming, and we wanted to consume both of these inside City, inside an existing application, and we did this successfully inside one of our dev branches of a real-world application that traders are using today. So we published the live market data from Thomson Reuters onto PubSub, and we had the consumer integration inside City. And then from there, the derived time series calculations that we can now produce, including correlations, we actually had up to 1,000 assets, and we were running these correlations at regular time intervals. So it's almost 1 million correlations at various times. And Google Cloud Platform had no problem scaling. But we also want to put those correlation values back into BigQuery. And then you start testing the system, stressing the system. How quickly can we ingest this stuff? And this was all part of our learning experience. So this is what it would look like if you were doing this stuff in Dataflow. So it's not too exciting. I won't spend too long on this, but just to show we really did this. It really did work. Across the top, you have all of the assets. We can't fit them all on screen. You have this sort of T-like structure. Each box across the top represents a different financial asset that Thomson Reuters was streaming to us. And then the pipeline down the middle is effectively doing those exact processes that I described with those diagrams of the price observations, building out the candles, calculating the correlations, and so on. So I think for us, next steps. So this is great. We do this already, right? This is not brand new stuff. But it was a nice test case for us because we were able to compare what we can do internally with our existing setup very cleanly with what we can do in the cloud. And we were also able to scale this in a way that maybe wasn't possible internally, at least not so quickly and not so readily. And I think for Citi and for a lot of financial institutions, our next challenge is to understand what data sets we want to move to the third-party cloud. And how do we want to do that? But when we break down data silos, anyone who's working in data analytics knows the fewer silos of data you have, as long as your data's in one place, the opportunity for getting insight from that data just grows massively. And so by having more of our data in the Google Cloud Platform, it will become possible to store it all in BigQuery for a start, but also then start looking at how we can get Dataflow to interact with Cloud ML My background's in machine learning. I'm really interested in this area, and I'm absolutely fascinated to understand how we can put city data together with market data and start doing more business-driven analytics and add value for our business. Thank you very much.
All right. So thank you, James. Thank you, Penny. Just thank you, everybody. I think this is the last session of the day. Thank you for being here. It's been really, really good event at GCP Next. Really happy to have come across the Atlantic and meet many customers and future customers here. And I hope you found all this useful and can take advantage of it as you go back to the office tomorrow morning. Thank you very much.
Ladies and gentlemen, there is a drinks reception now that you are all invited to attend. Please note, North Greenwich